Hello and welcome to the fourth demo of Step Forward, the application development platform. In this video, we will explore a concept of visual programming implemented as executable flowcharts in Step Forward. The concept of a flowchart is a very old one. In the early days of computer programming, the development would start with drawing a flowchart that was a graphical, step-by-step representation of the algorithm to solve the problem. This flowchart would then be turned into a computer program written in one of the programming languages, like Fortran or C or Java. The program then compiled into the executable code, and finally that code would run on the computer. In time, the flowcharting step faded away, although the image of the flowchart has always remained in the programmer's mind. Step Forward changed this traditional order of things, recovering the first part and short-circuiting the rest, thus eliminating the need in old-style programming. How this is done is the subject of this video. In our previous video, we have seen the market table that was supposed to be populated with data by a program, without human intervention. Step Forward provides the process feature for programming that implements the concept of executable flowcharts described above. Similar to data templates, flowcharts are made of components drawn from the palette. They are assembled in the workspace and fine-tuned in the inspector. One of the most commonly used components is the retrieval from the database that serves to extract data from the table and pass it to the flowchart based on some selection criteria. This component is so important and powerful that it merits a more in-depth discussion. In the palette window, in the middle column of the database browser, there are names of tables that have been created so far. The retrieval component is set to load data from the stock table when the flowchart runs. The fields column in the browser lists all data fields available in stock. We will add the ticker symbol field to the retrieval. Now let us look at the inspector. The retrieval tab offers us choices of how much data to return from the database table. The table contains multiple rows and it is possible to fine-tune the return data if needs be. However, in our case, we will ask for all ticker symbols stored in the table. Because typically we want to handle more than one row that the table contains, we may want to organize a loop walking through the table. This is done by dragging in the next row component from the inspector. Looking at the inspector, we see three more tabs. Search we will leave for another retrieval, since here we are not going to limit whatever comes back from the table. Instead, we'll select the Sort tab. Here is the list of fields that the returned data can be ordered by. We'll drag the ticker symbol to the top. And now we have the results of the table retrieval sorted by the ticker symbol alphabetically in the ascending order. To test the flowchart, we need to replace the parameter component that is put into the new workspace by default with parameterless start component. We will look at how parameters is used later. For now, just complete the flowchart by connecting the components. The flowchart is syntactically correct. Now we can test run it. The test window allows us to track the performance of each component, either stepping through them one by one or running them without stopping. Since this is our first encounter with executable flowcharts, let's step through it. What happened here merits some more explanation. First of all, we can see the SQL command created by the retrieval component that was sent to the database engine. Once the command has been executed, and it already has, the results are stored in memory like a stack of plates. In our next step, we will reach the decision-making component, which will do two things. One is load the first row, plate, in the stack into the variable provided for it, the field slot in the retrieval box. Second, it will check if there are still more rows in the returned stack. We can see the first ticker symbol returned from the stock table. Step again. And since there are still more rows, ticker symbols in the table, the control to green outline moves to the retrieval again and gets another ticker symbol. We can continue stepping until we run out of rows in the stack, or we can just let it run. Now that we know how data is retrieved from the table and passed into the flowchart, we can move to the next component, the function. Functions are components that encapsulate some solution to a specific task. You can think of them as black boxes that take something in as parameters and return something back as results. The inside of this black box is immaterial for the flowchart where the function is used. Once the function component is added to our workspace, the palette navigates to the Function tab, offering us a choice of functions available in Step Forward. Some of them are prefabricated system functions, others are made by the user function editor, and later on we will have a look at some of them. Right now we're interested in a function that is called stockvaluator. From the function description, you can see that its job is to pull the market data from the web for the given ticker symbol. The inspector shows us that this function takes one parameter as input and returns 4 values as output: high, low, and close price, and the trading volume. The inspector also gives a more detailed description of the parameters. We will set the ticker symbol parameter to the one that is returned by the stock table in the retrieval component. All we have to do is have the newly added function box selected and then navigate to the stock table in the palette and either click on the ticker symbol or drag it into the top function slot. Note that when the field is added, its name is expanded to qualify it with the table name. The other 4 fields are output fields, so we need the receptacles for them. These names refer to predefined constants and variables maintained by the flowchart. We will create 4 new variables. Every time we click on the new variable, a new one is created and added to both the function and to the local named list. We could leave them as they are and use them elsewhere in the flowchart, but it will be easier if we gave them meaningful mnemonic names. So let's rename them. Let's call this high. The square button to the left of the top field allows us to hard-code the value of the input parameter if necessary. For example, if we wanted the function to always return market data for the stock ry.pr.a, we could put it in the slot. But we want it to be more flexible and work in the loop, returning the data for each stock in the stock table. So we return it to the previous value. Let us now reconnect the components. And test it. The test window shows two values for each variable passed into the function, before the function was run and after, so that you can see the effect of executing it. We are now ready to store the market data in the market table. For this we will use the insert component. This component adds a new record or row in the database lingo to the table. In this component, we see two columns, the in-field column for the table field names and the value column for constants and variables used to set fields content. We populate the fields first by dragging in the fields from the palette. You can see the SQL insert statement generated by our insert component. Keep in mind though that in the test mode no real changes to the database take place. We will have to run the process live when the flowchart is ready to see the effect of populating the market table. But we're still not finished. There are a couple of weaknesses in our flowchart. First of all, we cannot keep the date hard-code, lest we are willing to keep making changes to the insert component every time we run the process. To help this, we can use one of the system functions provided by StepForward's inventory, current date. Now we have a variable that will carry the current date. We can plug it into the insert component. But there is still one more problem. When we add the new row with market data to the market table, it is stored alongside with all other copies of the same data. If we run this process 2 times in the same day, we will end up with 2 sets of market values for the same ticker symbol. And if we run it again, there will be a third copy of the same data. To prevent this from happening, we can delete all market data for the current date before adding it to the table. This way, we will always have only one set of values for each stock and date pair. Let us bring in another component, delete. The way delete command works on database tables is that it will delete entire content unless we add some selection criteria to constrain the effect of deletion. The Search tab of the inspector provides the mechanism to set these criteria. Here we have the list of all fields that make the market table. The ones that we drag above the top line become active and make part of the constraint. The default comparison operation for the constraint is equality. And the constraint value is entered in the text field. Just like with the insert, we don't want to hard-code any specific date. Instead, we want to delete all content for the current date for each ticker symbol separately. We'll also add constraint on the ticker symbol. Now we can try and test the flowchart one more time. Before saving the flowchart, we have to make sure that it is marked as selectable. If we don't label the process as selectable, it will be treated as a component to be used in other flowcharts rather than running on its own. Now give it a description. Let's call it update market data and save it. We can now run the process. However, before running it, let us set the stage for viewing the effects of this process. If we try loading data from the table, we will find that the table is empty, just as expected. Now we can run the process. And everything is locked up while the process runs. You've seen that running this process takes some time. This has to do mostly with the internet latency with data loaded from the web for each ticker symbol found in the stock table. And this tied up step forward. To avoid the freeze up, we can run the same process in the background. I'll empty out the market table to start over again, this time running the process offline. I'll just go through the back door and delete everything using SQL command. So the table is empty again. We will launch this process again one more time, but run it in the background. And see that the step forward now remains responsive while the process runs. And we already got some data. Finally, instead of having to remember to run the process manually in order to update the market data, we can schedule it. We can run it daily at say 4 p.m. after the markets are closed. And we now can see it marked as scheduled. This wraps up the force demo of Step Forward. You can learn more about the functionality and capabilities of Step Forward, or download Step Forward from this page and read on preferred shares design on our website. Thank you.